This is part 3 of the Java implementation for this November 24, 9618 variant 4.1, and we are looking at the third and final question, which has to do with the linked list. So let me scroll all the way to where it is on page 12 here. So it says here that a linked list stores positive integer data in a 2D array. The first dimension of the array stores the integer data. Then the second dimension of the array stores the pointer to the next node in the linked list. So essentially we have, let me see if we can quickly visualize what's being talked about here, because I'll be making reference to that later on. So imagine you can visualize it like so. We have a visual representation of our linked list right here. So let's say these are the two dimensions. So this is the first dimension. It's going to have an index of 0. This one is going to have an index of 1. Then for the elements, we have about 20 rows going all the way down, but I'll just do maybe 3 just to help you visualize what we're talking about here. So 1 and 2. So this would mean that this is the first dimension, this is the first dimension rather, and this is the second dimension, is it? So the first dimension we have the elements, and the second dimension we have the what? We have the elements, and we have the indices, as it were. So let's go back to the question. So the first dimension of the array stores the integer data, then the second dimension of the array stores the pointer to the next node. So essentially this would mean that this is where you have the element, and this is where we have the index. So element, index here. So essentially we are saying that an element is stored adjacent to its index position. So this the second rather a linked list node with node data is initialized with an integer of -1. These nodes are linked together as an empty list. A point of -1 identifies that node as the last node. Then the linked list can store 20 nodes. So that's going to be the length of the other dimension for our array. The global 2D array linked list stores the linked list. Linked list is initialized as an empty list. The data in each node is initialized to -1. Each node's pointer stores the index of the next node. The last node stores the pointer value -1, which indicates it is the last node. Then the global variable first empty stores the index of the first element in the empty list. This is the first node in the empty linked list when it is initialized, which is index 0. Then the global variable first node stores the index of the first element in the linked list. So there is no data in the linked list when it is initialized. So first node is initialized to -1. The diagram shows the content of the initialized array. So here's an example of the initialized array. Right, so you can see that with index position 0 through 19, then data, remember it's going to be initialized to -1. That is for each node. Then the pointer is going to be 1 through 19 before we set the last node to -1, because the last pointer it's not pointing to any other elements in the list because it is the last one, so it's going to be -1. So we have to write program code to declare the linked list, the first node and the first empty. And now if you go back to here, you see that these are global variables, is it? So if they are global, it simply means that they are not declared outside of any classes, but outside of any methods. So they are declared inside of the class. So that's what we are doing here on lines 5 through 8. So with the size of the list size, which is essentially 20, I declared it as a constant right here. Then we also have the linked list variable array, rather 2D array, and you can see that we set the size to 20 and 2. Then we have the first empty set to 0 as described here. Then first node is going to be equal to -1 again as described here. So you would go ahead and copy this, paste it inside of the evidence document. Then moving on to B, the procedure insert data takes 5 positive integers as input from the user and inserts these into the linked list. So each data item is inserted at the front of the linked list. The table shows the steps to follow depending on the state of the linked list. So in the event that it is not full, we are going to perform this set of operations. Otherwise, even in the event that it is full, we are simply going to end the procedure. So any node that is at the end of the linked list has a pointer of -1. The program code for insert, right program code for insert data rather. So let's scroll down to where I have the implementation of insert data, lines 37 through 58 rather. So we create a scanner object, then we prompt the user to input 5 integer variables before we use a loop that's going to essentially input the values. Then we are checking to see if first empty is -1, at which point we are going to insert that the list is full. Otherwise, we are going to take the integers that have been input by the user and store them inside of the linked list. Then you would go ahead and copy this code and paste it inside of the evidence document. Then let's move on to part C. Here it says here that the procedure output linked list outputs the data in the linked list in order by following the pointers from first node. Write program code for output linked list. The implementation is right here, line 60 to line 66. So we are not doing anything fancy here, right? It's just a simple output, and what we are doing is that we want to output the data, right, followed by the pointer, right? So essentially we are just using a while loop to output the current node and its index position. So that's what we're doing right here with the output linked list function. Then you go ahead and output and copy this code and paste it inside of the evidence document. Then amend the main program to call insert data and then output linked list. So let's go all the way to where we have the main method. I can comment out this part because it's for later. So we just want to output, first we want to call insert data, then we also want to output the linked list as it were. Alright, so before we call insert data as required right here, where is it? Right here. Before we go insert data and output linked list, I want to show you what I had done for my implementation. So you see that I have this initialize linked list function going on here. So essentially, if you go back to this part, to this diagram rather, you see that all the data has been set to -1, right? And the pointer, there's values 1 through 18 before the last one is set to -1, right? Because that is the last node, the last pointer, as it were. So what I had done in my implementation is that I have this initialize linked list function, which essentially I'm calling before any other code inside of the main program there. So the idea is that I'm setting everything else to the data to -1, all of the data to -1, because it says here that the diagram shows the content of the initialized array. So I'm initializing my array to the default data that they've given us in this case. So my pointer, then I'm setting it to these values of 1, 2, 3, 4, all the way through to -1. So that's why you see that I'm calling this initialize linked list function right there on line 11 before I go ahead and call insert data right here. So that's a bit of explanation of what I'm doing there. So here we now call insert data as required, then we are going to call output linked list. Then let's go ahead and run this and see what we get down there in the console. Okay, so we are supposed to now test with this data that's given right here. So let's put 5, 1, 2, 3, and 8. And you see that our initial linked list is going to have those values, right? And then you'd go ahead and copy this and paste it inside of the evidence document. Then let's move on to D. So the procedure remove data removes a node from the linked list. The procedure takes the data item to be removed from the linked list as a parameter. So already we know what we need to do, remove data. Let me just go ahead and comment it inside of main here because we are going to be calling it shortly. So let me just uncomment this part so that I get rid of that warning on my remove data function here. So the data that is going to be removed is going to be taken as a parameter. Then the procedure checks each more node in the linked list, starting with the node, first node, until it finds the node to be removed. This node is added to the empty list and pointers are changed as appropriate. The procedure only removes the first occurrence of the parameter. So that means any other occurrences of the parameter are going to be ignored. Assume that the data item being removed is in the linked list. Write program code for remove data. So this is the program code for remove data, right? It satisfies these conditions. So we are using a loop and then some if statements inside, a set of nested if statements rather, to check to see if the parameter that was passed as an argument is inside of the list. Then if it is inside of the list, we are going to remove it and we are going to update the pointers as appropriate. Then after writing this code, you then go ahead and copy and paste it inside of the evidence document. Then going back to item 2, it says here that amend the main program to call remove data with 5 as a parameter. So coming back to my main program, you see that I'm passing 5 as an argument to the remove data function, then output the word after. So here after removing 5, then we call output linked list. Then after that, we simply copy the code and paste it in the evidence document, then come to the final part here, which says we should test our program with these 2 sets of test data. So let's go ahead and run this, and we input 5, 6, 8, 9, and 5 again, then the output. So you see that in the first instance it's just removing this 5 only once. Then after removing that 5, it's not going to remove any other occurrence of 5 in the linked list. So this is the initial linked list and this is the final linked list after removing 5. So this is for the first piece of test data. Let's do it with the second piece of test data. So running with 10, 7, 8, 5, and 6. So you see that is going to remove just the 5 and update our linked list as it were. Then you would go ahead and copy all this code, rather take a screenshot of the output and paste it inside of the evidence document. And so we have come to the end of the Java implementation for this particular session, and this was the November 2024 session of the 9618 variant 4.1 paper. So that's just about it for this episode. I'll see you in the next one.